in this post-war age we live in, GPUs are relying on software-based machine learning to get more quote-unquote performance. How do you think CPU makers will get more performance since ML is a more GPU-specific technology to begin with? I think my quick answer to that, I don't know what you think, Alex, is that we've kind of already got a CPU benefit from machine learning technology, but it is the GPU doing it, which is frame generation. Where you hit the limits of rendering because the CPU can't feed the GPU enough data, and then the GPU just says, okay, I'll just interpolate then. we'll get many, many more frames. It's an interesting conceit, though. What do you think?
I mean, I think CPU progress is stalled to a certain amount about what I think we are really limited about how wide games can go in a reasonable way, on how many cores they can use efficiently, and actually where it increases the base performance without any detrimental effects, like introducing too much latency, for example. We've seen games in the past where they go wider and they have to introduce latency to do it. In fact, that's one of the ways, it's not a bad thing necessarily, but it's one of the ways, for example, that Witcher 4 demo ran at 60 is they said, okay, we're going to induce more latency to make this possible. And those are trade-offs. And at the moment, I'm actually a little bit concerned about CPU scaling into the future because we have yet to see any great tangible game releases that we've covered, at least, where I say like, oh, this runs amazingly when you run it on a 12-core PC. So much better than an 8-core one, right? We have yet to see that. We have instead seen, oh, AMD put a F ton of cache on this thing and it runs every game better. And
with 8 cores.
With 8 cores. And, we've seen hyper-threading regression in terms of like actually offering tangibly better performance in games. We've seen the E-cores, as John knows all the time, loads up a game. E-cores are making my performance crap. We aren't seeing this.
Actually, Space Marine 2 was a good example of that, where disabling the E-cores did actually help significantly in my case.
Yeah. So, I think we really need game development and software development paradigms to shift. Everyone always talks about like Rust being the next way forward in this direction. I don't know, but I think this is less so a hardware problem than a software development one on the CPU side, because there's just stuff you can't parallelize easily. And if you do, then you run into whole other questions of like, does every gameplay programmer need to be like a multi-threaded specialist, or can they just write gameplay code and not care?
So going back to ML, the approach is basically to add an NPU to the CPU. That's basically what's been happening, and that's kind of almost a non-starter for games because you've basically got to send data to the NPU and then back again, and it's not great, is it? It's not a good solution for augmenting a CPU with ML. It does seem to be the case that you should just stick to doing it all on a GPU, really.
Right. I agree with that, especially like the stuff that it's currently applying to and where it's going to apply to. We really want to accelerate the visual aspect of games. And I think the other aspects, I have yet to see great tangible demos of it being useful. Like, I don't even know what they would be at this point in time, but I feel like the visual aspects for ML are like much more approachable than any of the other stuff I've seen so far. Because all that stuff seems to be offline anyways. Like you run an ML model to generate the terrain on a planet, for example, in a game, or the terrain, instead of, having it being done in some other simulated way or artist-driven way. And I think that is all offline processes that have nothing to do with the real-time game performance.
I think the other thing is that all of the rumors are indicating that the next generation CPUs are going to be just like doubling up on cores again, which is great from our perspective as creators, because we need lots of CPU power for, all of our production tools. But for gaming, it's basically a non-starter. And that was kind of showing up by the X3D chips, where AMD just basically said, well, let's just stick on a massive amount of cache. and suddenly you've got like market-leading CPU performance.
Yeah.
It's just the way things are going. I mean, I guess the other thing, of course, is, we've often talked about Red Engine, Cyberpunk 2077 having excellent CPU scaling. But even then, it wasn't like dramatically improved by doubling up on cores or tapping into e-cores, was it? It was just a nice to have, as opposed to like a game-changing experience that you'd expect from having so many extra cores.
That's where it is. It wasn't detrimental, so that's why it was so nice.
Yes, it wasn't bad.
Yeah. So it wasn't like life-changing or anything like that.